First thing, introduction, put a heading and write it down. Protons, neutrons, and electrons constitute an atom. Some of the electrons in a metal are free to move around. These electrons are called free electrons. I want you to just bullet free electrons. This is the definition of free electrons. If in photoelectric effect, they ask you what is free electrons, you need to write that definition, that some of the electrons are in the metal are free to move. They can move around anywhere, and these electrons are called free electrons.
Are they the same as delocalized electrons?
You can say localized electron, but remember that that term which you just said, localized electron, this belongs to chemistry, technically speaking. So, yeah, localized, delocalized, every science has its own terms. Like, for example, I've told you, like, atomic number is not used here. We called what do we call atomic number here in physics? Nucleon number is called as mass number here. So, in physics, the terms are named differently. You're right. It's localized or unlocalized or whatever it is. But remember that here we use a word called free electron. So we need to know the vocabulary which can be used over here as well. Rather than using chemistry vocabulary, try to focus on the physics one. The one you are saying is absolutely right, by the way. It's no issues at all. If you use by any chance, by mistake, you use that word localized or delocalized word, it will be fine. But rather than that, why don't we use the terms belongs to physics? All right. Okay, next bullet point. It's in, bullet points. To remove these free electrons from a metal, energy is required. Energy is required because they are held in a metal by electrostatic attraction of positive charged nuclei. Positive charge nuclei. Next bullet point, the electron must be given energy. Electrons must be given energy in order to escape from the surface of a metal. Electron must be given energy in order to escape from the surface of metal. Next bullet point. If this energy is in the form of light energy, then this phenomena is called photoelectric emission. And this effect is called as photoelectric effect. This effect is called as photoelectric effect. After that, I want you to draw this diagram. Very important. Very simple diagram is here. If you check this out, a power supply is connected to emitter and collector. Emitter means which will emit, and collector where you will collect. You can simply think of it. So what you will do, you will fall the light on the emitter through the incident light, and this collector will collect the current. What is this microammeter? Because the current will be very small, that's the reason we are using microammeter in series to check whether there is a current or not. Right? Now, why this power supply is connected, by the way? Can anybody tell?
For current?
But if the current is we apply the current, then how will you check the current value then?
Through the microammeter.
The reason is we are giving these positive and negative terminals, because if you don't provide in this way, then actually this whole setup will not work. We have to provide the voltages so that we will have some positive or negative electrode. If you check this out, What it says is photoelectric emission is defined as the release of electron for the surface of metal when electromagnetic radiation is incident on its surface. The electrons that are released in photoelectric emission are called photoelectrons. An experiment shown is used to investigate the energy level of the photoelectrons. All right. So very simple cases. How do we actually perform that? Oh, sorry. We don't have actually this in proper course, but for the time being, just remember one thing. We got a small sort of a box or something, you can say, from where no light will be actually escaped out, you can say. Now, if you check this out, on an emitter, you are actually bombarded incident radiations, incident light, okay? Now, this light is a monochromatic light, remember that? That's the reason this light may be very strong, highly frequent light, okay? Now, this light will be emitted on this emitter and then current start flowing as well. Now, what is the purpose of this collector? As the name suggests, collector. So, collector will start collecting the current. You can say through emitter, the electrons moving towards the collector, and that collectron will take the current and will complete the circuit. And this ammeter will be used to actually checking that small amount of current. Why do we use this micro ammeter? Because that current which actually start flowing due to photoelectric effect will be very, very small to measure. That is the reason the ammeter which is used over here is a micro ammeter. Okay. The voltage around that will be showing as a voltage. So now I want you to put a heading here. Put a heading of photoelectric emission and write this definition, please. Photoelectric emission is defined as the release of electrons from the surface of metal when electromagnetic radiations is incident on its surface. The electrons that are released in photoelectric emission are called photoelectrons. All right. Just write till here, please, and draw that diagram. Do not draw this diagram, just write this definition. I will tell you what diagram you need to draw. Just leave some space for that, okay? We will draw the diagram later on. Not this one, there will be another diagram. So if people will ask you what is photoelectric emission, Alicia, what do you say? Yes, Alicia. What will be the definition of photoelectric emission? Or Zoha or Mahnur?
I'm sorry, can you repeat the question?
My question is, what is photoelectric emission?
Hello?
Yes, photoelectric emission.
Hello?
Yes, can you hear me? Yes, photoelectric emission. Zoha or Mahnur, you?
I can say it's the release of electrons from a metal surface when there is electromagnetic radiation present on the surface.
Or you can say it will be bombarded with the electromagnetic radiations. Right? Very simple.
Yeah.
So the electrons which are ejected or released, those electrons are called as photoelectric or photoelectrons, you can say, or photoelectric emission. Right? Now let's see further. There are further definitions which are there now. Now check it out. The experiment that can be performed using ultraviolet radiation of different frequencies when maximum kinetic energy of photoelectrons is plotted against the frequency of radiation, following graph will be achieved. Now check this out. This graph you don't have to draw right now. First of all, let's write these definition one by one because these are the terms which will be used one by one. First is called the work function. What is work function? The minimum amount of energy necessary for an electron to escape from the source is called as work function energy. Just write that down. This is the sign called work function. Then you got threshold frequency. That is a minimum frequency required to knock out electrons from the metal surface. We have done this, or for the metal emission to take place, we need this minimum frequency or threshold frequency that actually will knock out the electrons from the metal surface, right? So this frequency is called threshold frequency. I want you to write work function and then threshold frequency, please. Students, any problem in understanding these terms? Work function, threshold frequency, or till now,
No,
whatever,
it's good.
right? So whatever we have actually gone through yesterday, it's all that theory. But I want you to write a proper notes for that so that notes will be available once we will be solving the past papers. Okay. Here the threshold frequency is written as F naught. Remember that there is another way of writing that as well. This sign that is called phi. So sometime you can find this as F naught. Sometimes you can find this in that sign as well. Don't be confused. Both means the same. So write with F naught. Write also this one as well. This sign.
Okay.
Yes,
What's
sir.
after this?
After this, now the another very important thing, that thing you have already told me last time that you want to know about the Planck's and all these. So Planck's energy E is equal to H frequency. What is this all, right? So here I want you to put a heading Einstein's theory of photoelectric emission because this energy is given by actually the Planck's, another scientist. So I want you to write this one as well. The German physicist Max Planck suggests that the energy carried by the electromagnetic radiation might exist as a discrete packet called quanta. And the energy carried in each quanta is given by the following equation. E is equal to HF, or E is equal to H mu. Mu means Fs. Now this is all what you go. H is equal to a Planck's constant. The value is 6.63 into 10 raised to the power minus 34 joules second. And F is the frequency of the radiation. You have to just write till F. Don't write the next few lines. I will let you know what exactly you need to write. Once you finish with that, F is equal to frequency of the radiation. Let me know.
I'm done.
Done. Okay. What about the other two, Mahanur and Alicia?
Yes, sir, done.
Done. Okay. Now another thing.
Yes. Yeah.
Done. Now what do you need to write here? Now I want you to write a heading. That heading say the result prediction of photoelectric effect. The results prediction from photoelectric effect. You know that place where actually you were doing this diagram. I want you to draw, please. I told you to leave one small space for the diagram. That is a diagram you have to draw. First, you draw that diagram, and then let's come back to again. Let's come back to the point where we leave it. Okay. First, draw that quickly. It's very easy to draw. It shows that the light ray in the form of photons you are falling on, and electrons are coming out. That's what it means.
Sir, I have one question.
Please.
In class, in school, we have been taught one more equation, which is HF is equal to E. Sorry, I got cut off.
That's okay.
HF is equal to E1 minus E2.
Yeah, that's fine. So what's the big deal in this? Difference
I
of
don't.
energy. See, can you tell me the equation? There are different ways of writing a same equation. If you check this out, how do you explain this work function? For example, you can say E photons minus kinetic energy. That will be equal to phi. So actually, technically speaking, both are energies. So this is the energy of photon, which actually fall, and this is the kinetic energy of the electrons, which are getting out of the metal. So if you subtract these two energies, technically you got the work function. because work function is the minimum energy that is required to knock out the electrons from the metal surface. So when you subtract this energy, that is the photon energy from the, I mean, kinetic energy from the photon energy, you got the work function. So you can write this equation as E1 minus E2 as well. Not a big deal. What's the problem?
Okay. I
See,
just wanted to confirm.
that's fine. That's fine. No problem at all. That's your class. You can ask any question you want until you are satisfied and until you are, you know, everything is clear in your mind. Okay. Now, prediction based on the light. Now, what was the heading you just put it on? Yes, what was the heading you just put? The heading was prediction on the photoelectric effect results. Prediction about the photoelectric results. Photoelectric, not photoelectric, photoelectric effect results. Predictions on the photoelectric effect results. Put a heading this and write the first point. To explain the photoelectric effect, 19th century physicists theorized that light is a wave, so that electric field of incoming light wave was heating the electrons. The electric field of incoming light wave was heating the electrons and causing them to vibrate, and eventually freeing them from the metal surface, and eventually freeing them from the metal. Second bullet point. Scientists also believe that the energy of the light was proportional to its brightness, which is related to the wave's amplitude.
Is it directly proportional to the wave's brightness or indirectly proportional?
Directly. That's what we have done in young modulus experiment.
Yes.
Okay. So in the nutshell, based on the classical description of light, based on the classical description of light as a wave, they made the following predictions. Number one, the kinetic energy of emitted photons, should increase with the light amplitude. Second prediction, second bullet point. The rate of electron emission which is proportional to the measured electric current, should increase as the light frequency is increased. Okay. Any problem in this?
No, it's okay.
It's the same thing.
I have one thing to say. Will you teach us about energy levels and spectra?
Of course. Yeah, after this, we have that topic. Don't worry about this.
Okay,
As soon as we
because
finish,
we already talked about heating um, electrons, therefore they get ejected. So I remember that is to do with the spectra. So I was thinking,
of course, as soon as we finish, because this is the last, not the last actually, this is the last very big topic. So we have to cover this topic with very much care. This is not the small one. Once we finish with that, we will come to the radiation and all these, that energy levels and different kind of, other than the neutron, proton, and electron. We got so many things in that. So it's all, inshallah, we will cover it up. Once we cover that one up, then we will start the new unit. Before that, everything will be covered, hopefully, inshallah. Okay?
thank you.
No issues. Okay, now the results of photoelectric effect. Put the heading now. The results of the photoelectric effect, or the actual results of photoelectric effect. All right. First result: the kinetic energy of photoelectrons increases with the light frequency. Second bullet point: electric current remains constant as the light frequency increases. Electric current remains constant as the light frequency increases.
I don't actually understand what do they mean by current is constant with frequency. What does that really mean?
Actually, it means that you're changing the frequency. Like, for example, let's take it as an example that instead of red light, now you're throwing a blue light. Definitely, it has a different frequency, right? Then instead of blue light, you're throwing, let's suppose, violet light. Now you're continuously changing the frequency, right? By changing the frequency, the current passing through the conductor should change up, if it all depends on the frequency, because that's what our belief was when we were talking about light as a wave. That frequency is the one which causes the current to change. Like, for example, if you're using a red light, because the more frequency, more powerful ray, less frequency, less powerful ray. But here the case is different. The current remain constant whether you put any light, the most penetrating light or less penetrating light. So it basically didn't affect it, but rather the frequency is all depending upon frequency gives more kinetic energy to the basically metal, so that electrons, it mostly knock out the electrons from the metal surface. Rather than current move in the circuit, they are just giving kinetic energy rather than increasing the current value, because at the end of a day, these all electron means the current. So we are not getting more current if we change different frequencies. That's how we actually checked. Because initially what we were thinking that changing the frequency will cause more current. More penetration or more penetrating frequency means more current. But that will not actually, that didn't happen. We change different frequencies, we find the same amount of current. Understood?
Yeah, so for example, we're shining red light, it has less frequency, but
Yep.
let's say the current is at um 6 amps.
Not 6 amps.
Would
6 amps is very big value. It will be somewhere around in microamperes or somewhere in milliamperes. Very small current.
Okay, but just for example,
Mhm.
it would still be that really small number if it was blue light. So let's say
Absolutely.
0.3 milliamps for red light, it would still be 0.3 milliamps in blue light.
Absolutely. So basically,
Okay,
changing of the frequency didn't affect the flow of the current. You can say like that.
okay, now I understand. Thank you.
No issues. But it definitely affect the kinetic energy of the electron. The amount of electricity is less, but whatever electron you have it, they got more and more kinetic energy. It's same like that, for example, I don't know, I didn't. I don't know whether I have to give that example or not. I've seen through a movie actually, a very interesting movie. You know that movie is a gangs, a sort of fighting gangs. One person bring a whole army of 100 or 200 people, and one person bought one person only. And when people ask you where is your army, he said, "This is my army, one person." People are saying you are stupid. On the other side, there are 200 people, and you got only one person. He said, "I'll show you what this person is capable of." And that person is basically the that Greek god. I forgot the name of the power god. Do you remember the name of that Greek power god?
I don't lose.
Yeah. So that one person is more than powerful than those 100 people. So same condition is here. You got the number of electrons in each and every case. Let's suppose, as you just said it, 6 milliamps or 2 milliamps or 4 milliamps, whatever the current is, it's constant value. But whatever current you have it, the energy level for each and every frequency case will be different. Energy of those electron will be different. Now, do you understand that? Yes, bro.
Yes, that makes a lot of sense.
So this example is making a lot of sense now. One person with more power and 100 people with a less power, it's the same case. Okay. So I want you to write these 4 bullets point now. Energy current increases with the light amplitude. The kinetic energy of the photoelectrons remain constant as the amplitude increases. Once you write all the 4 points, give me a shout, please.
I'm done.
Okay, now I want you to write a new paragraph. You have written all the bullet points. Now write a paragraph. The new model was developed by Albert Einstein. The new model was developed by Albert Einstein, who proposed that who proposed that light sometimes behaved as a particle of light sometimes behaved as particles of electromagnetic energy, which is called photons, which is called photons. The energy of photons can be calculated. The energy of photons can be calculated can be calculated using Planck's equation. E photon equals to H frequency, H mu, where E photon is the energy of photon in joules, where E photon is the energy of photon in joules. H is a Planck's constant. H is a Planck's constant. And F or mu, it's written mu by the way, but you can write F as well if you have problem in writing this sign. And F or mu is the frequency of the light. According to the Planck's equation, according to the Planck's equation, the energy of photon is the energy of the photon is proportional to the frequency of light. To the frequency of light. to the frequency of light, and the amplitude of light is, and the amplitude of light is proportional to the proportional to the number of photons with a given frequency. Number of photons with the given frequency.
I don't understand that amplitude is proportional to the number of photons with a given frequency. What does that mean?
It means that actually, as we just discussed previously, on a particular, as far as frequency is concerned, now there are two conditions. One condition is, let's suppose you are making this amplitude as a constant, you are putting different frequencies. When different frequencies you are actually applying, you found out that the current value, or in other words, number of electrons will be the same, right? So number of electrons or the current value is not increasing, right? So basically, frequency is nothing to do with the current value. You change the frequency, you increase or you reduce the electrons, right? The second thing is now amplitude of the light. Now, let's suppose the frequency is kept constant and you are changing the amplitude. Now, amplitude is basically everything to do with the number of photons with the given frequency. Now, definitely, it will be, now we are talking about the photons. Let's suppose at one amplitude of a given frequency, you are providing, let's suppose, 2 photons, right? Now you increase the intensity or you increase the amplitude. Now instead of 2 photons, you are providing 20 photons. So 20 photon provide more current. Am I right? See,
Yeah.
actually, it's the same thing as a current. Point is, at one frequency, one specific frequency, let's suppose you start increasing the amplitude. Now, my point is, how do you increase the amplitude? It means that at input side, what you are doing, you are increasing the amplitude of the photon. So amplitude, how to increase that actually? Amplitude of the light is then proportional to the number of photons with a given frequency. Initially, you are providing 1 photon or 2 photon or 3 photon. Now, increasing the amplitude of the light means you are increasing the photon numbers now. Okay. So that's what it means. Okay. Shall we move on?
Yes.
Okay. Now let's move on. Now I want you to write this one quickly. According to Planck's equation, the energy of photon is proportional to the light frequency F, and E is equal to H frequency. Now the light frequency F is inversely proportional to the wavelength. So C is equal to lambda V. Where C is the speed of light, that means that increase the wavelength, decrease the light frequency. Therefore, wavelength of a photon increasing, its energy decreasing. Now, instead of frequency, they are comparing, or they are actually observing the lambda. Frequency increase will increase the kinetic energy of photons or electrons, whatever you want to say. Here, reducing the lambda will increase the kinetic energy now, because lambda is inversely proportional to the frequency. Okay. So I want you to write this paragraph. Okay, students, have you written that?
Yes.
What about Mahanur and Alicia?
Yes.
Okay. Okay, now once you write this one, now let's come to the actual equation. We have write this all and everything here. Now this is the graph which I am actually interested on. So write down the heading graphs. Then write under the graph, put a heading, the graph between the frequency and the kinetic energy of the electrons. Light frequency and the kinetic energy of the electrons. Draw this graph first, and the graph, okay, first draw this graph. Draw that graph, first one as well as the second one. Now write few lines if you have already drawn that. Put a heading explanation. The scientists observe that if the incident light had a frequency less than a minimum frequency, if the incident light had a frequency less than a minimum frequency mu naught, then no electron were ejected. No electron were ejected regardless of the light amplitude. So it means that if your frequency is less than the threshold frequency, whether your amplitude is more or less, electron will not be ejected. For ejection of the electron, you must have to give minimum required frequency that is required to actually knock out the electron from the metal. And that frequency is called as, this minimum frequency is called as threshold frequency. That minimum frequency is called as threshold frequency. The value of mu naught depends on the metal. Any problem till now? Because these are all the things till now. Like if question will ask somewhere like another, this kind of question answer you have to give. It depends what question they ask you. You don't have to write each and everything. That's the reason I am actually asking you to write the headings, so that if somebody will ask you any question, you have to write that specific headings, or you have to write as per the accordance with the question. Okay. So now another graph, we didn't actually show that. On a given specific frequency, as the amplitude was kept constant, the number of photons being absorbed by the metal remain constant. So graph between light frequency and the electric current is shown. Okay, students, tomorrow I will not be able to take your class. Inshallah Aziz, next time we will take our 5 classes, everything. But this week we will only have 4 classes till now. I think we had 4 classes altogether. Yeah, I think this is our 4th.
Yes.
So we didn't have our 5th class, but anyway, I will try to compensate you your 5th class in the next coming weeks. All right, but not this week due to some reason. All right.
Okay.
So now our
All
class
right.
will be on Monday now, rather than we do not have any class on Sunday. Okay. So I want you to go through this photoelectric effect, and there are a few more things which I have to actually dictate you. Once this will finish, then we will come to the things which Zoha actually just pointed out. That energy levels and everything. This is something related to the chemistry, but definitely we will see those, and hopefully we will do that. Okay. But just go through this topic. Photoelectric effect is the most powerful, or you can say most important topic to understand, because this is the basis of your quantum mechanism and everything. All right. Okay, then take care. Bye.